Hi there and welcome to the video. In this video we are going to talk through how to convert recurring decimals into fractions. So a recurring decimal, like 0.4 recurring, is a number when the decimal is repeated indefinitely. So it might be a single digit or it might be more than a single digit, but there will be a repeating pattern that is repeated indefinitely. First thing we should look at is this notation here. This dot above the 4 is telling me that this 4 is recurring. So I'm actually dealing with the number 0.44444 and on for infinity. But rather than writing out lots of 4s, we often use the notation of putting a dot above the 4. You may sometimes see this as a bar in certain textbooks as well, but the notation I'm going to use in this video is the dot above the number to show that it is recurring. When we're dealing with a recurring decimal, the fact that it recurs tells us that it is a rational number, which means it can be presented as a fraction. And that's what we're going to look at in this video. Let's look at this first question. Can we convert 0.4 recurring into a fraction? Here is what my method would look like. Okay, I'm going to start by looking at the left-hand side of the screen. So what I've done is I've took the number in the question, 0.4 recurring, and I've labelled it x. So I've brought in a bit of algebra into my working out, because the algebra is going to help me convert into the fraction. So if x is the number in the question, 0.4 recurring, if I was to times that by 10 to find 10x, 10x would have to be 4.444 recurring. So all I've done there is I've multiplied by 10, which has meant that the decimal place has moved from here to here to give me 4.444 recurring. So what I'm aiming for, as you can see from the green line, is to get the digits after the decimal point to be the same. So all of these 4s, which would continue on indefinitely, are now exactly the same as all of these 4s. So we've lined up, we've matched up the tails of the digits after the decimal point. And once we've done that, we can then go ahead and convert it into a fraction. So what I'm going to do is I'm going to take my 10x, which is 4.4 recurring, and I'm going to subtract away my single x, which is 0.4 recurring. So when I come to do the subtraction, 10x take away x leaves me with 9x's. And this number subtract this number, because the digits after the decimal point are the same, they would be removed because we're subtracting one from the other. So they would be removed from the calculation. So essentially what I'm doing is 4 take away 0, giving me 4. So now I'm left with 9x equals 4. I'm just going to solve that one-step equation by dividing both sides by 9, which is going to be 4 over 9. So the number 0.4 recurring presented as a fraction would be 4/9, 4 over 9. And this is the standard method of how you approach all questions about changing recurring decimals into fractions. No matter how complex the question gets, this method, by bringing in algebra, will always help you get to your answer. Let's have a look at another example. So this time I'm asked to convert the number 0.52 recurring into a fraction. So notice that the dot is only above the 2. So the 5 does not recur, but the 2 does recur. So I'm going to go ahead and approach this in a similar manner that I did the first example. Here's my working out. Again, I'm going to look at the left-hand side of the screen first. If I was to label the number in the question 0.52 recurring as x, I'm going to aim to get the digits after the decimal point to be equal, to be the same, to be matching. So I'm going to have a look at 10x, which would be 5.22222 and so on. But then if I compare 10x to x, you can see because of this 5 and that 2, the numbers after the decimal point are not matching. So this time I need to take this a step further. Now I'm going to look at 100x. So I've moved the decimal place twice to give me 52.22222 and so on. So now when I compare the 10x to the 100x, my digits after the decimal point are the same. That's shown by the green arrows in my working out. So in this subtraction, I'm not actually going to use x. I'm going to be interested in 10x and 100x because it is at this point where the decimals, the digits after the decimal point are matching. So then I go ahead and do a subtract. 100x take away 10x is going to leave me with 90x's. 52.2 recurring take away 5.2 recurring. The tail of this decimal and the tail of this decimal would cancel out because we're subtracting them, leaving me with 52 take away 5, which leaves me with 47. Then I divide both sides by 90 to tell me that the value of x is 47 over 90. So 0.52 recurring, presented as a fraction, would be 47 over 90. Let's have a go at another question. You have the ability to pause the video and go ahead if you want to have a go at this question yourself, or you can wait for my explanation. There will be some questions later on in the video. I want to convert 0.123 recurring into a fraction. First thing to look at is the notation. We've got a dot above the 1 and a dot above the 3. That does not mean that just the 1 and the 3 recur. What it means is all the digits between the two dots recur. So this number is actually 0.123, 123, 123, and so on. So even though there's not a dot above the 2, because it's in between two digits that have dots above them, we can assume that it also recurs. Here's my working out. Again, my aim is to get the tail of some decimals to be matching. So I've labeled the number in the question as x, 0.123, 123, and so on. When I thought about 10x, that was going to give me 1.23, which would not have lined up correctly. Then I thought about 100x. That would have given me 12.312, which again would not have lined up correctly. So then I go ahead and think of 1000x. This gives me 123.123, and so on. So you can see from my green underlines that I've now got the digits after the decimal point, they are matching. So now I can go ahead and do my subtract in order to find my fraction. 1000x take away an x is going to give me 999 x's. Because the tail of these decimals now match up, when they subtract, they'll be removed. So I'm left with 123 take away 0, which is 123. Then I divide both sides by 999, which is going to give me 123 over 999. And as always with fractions, if we can simplify the fraction, we would go ahead and simplify the fraction. So it does not matter how complex the question becomes, we're always aiming for the same thing. We're always aiming to look at x, 10x, 100x, 1000x. Maybe we have to go to 10,000x. But we're aiming to find the digits after the decimal point to be the same, to be matching. So then we can remove them during this subtraction. Okay, so now it's your turn to have a go at a few questions. I put 2 questions on the screen I'd like you to use an algebraic method similar to the method I've talked you through at the beginning of this video to show how you would convert these recurring decimals into fractions. When you unpause the video, I'll talk you through my worked solution and you can compare your answer with mine. So for now, could you pause the video and have a go at these two questions? Okay, welcome back. Just have a look at my answer for 0.8 recurring. So this is what my full method would look like. Your answer should look something like this, applying an algebraic method. So you're labeling 0.8 recurring as x. Of course, you can use any number. I generally go ahead with x, but you could have used n. You could have used any number, as long as you are bringing in a bit of algebra to label your original number 0.8 recurring. So therefore, 10x has to be 10 times that. So 8.8 recurring. So now I have this line of digits and this line of digits matching. I can go ahead and do a subtract. 10x take away x is 9x. 8 take away 0 is 8, because these lines of digits would be cancelling out due to the subtraction, leaving me with 10x equaling 8. I divide both sides by 9, telling me that x is 8 over 9. So 0.8 recurring as a fraction is 8 over 9. My working out for 0.27 recurring. So this time x is 0.272727 and so on. I have a little look at 10x, 2.7272. But this time the decimals do not line up. They're not in the correct order. They're not matching. So then I went ahead and had a look at 100x, 27.2727 and so on. So now I've got my value for x and my value for 100x with the digits after the decimal point matching up. So I go ahead and do my subtract, leaving me with 99x equaling 27, which would take me to 27 over 99, which of course I could simplify down to 3/11ths. So again, the process is important. When we look at the exam questions in a few slides' time, you'll see that the examiner will always ask you to show that and show your full working in order of how you got your fraction by applying algebra. Very well done if you got these two questions correct. Okay, another two questions for you to have a go at. Again, could you pause the video at this point, show me a full algebraic method of how you would convert these recurring decimals into fractions, and then when you unpause the video, I'll show you my worked solutions. Okay, welcome back. Let's have a little look at my worked solution for the first question. So when we approach this question, you need to notice that it's the 3 and the 8 that recur. The 2 is not recurring in this question. You go ahead and think about x, think about 10x. You may also have thought about 100x and then also 1000x. When we look to see the tails of the decimals matching up, it is 10x and 1000x we are interested in. The fact that this 2 does not recur suggests that I won't be using this x, this single x, in my subtraction. I go ahead and do the subtraction, which will cancel out the tail of these decimals, leaving me with 990x equaling 236. I divide both sides by 990 to get this fraction here, 236 over 990, which I could simplify down. So a very similar process to all as I've been doing it throughout the video, but just needed to take into account that this 2 was not recurring, but the 3 and the 8 were recurring. Let's have a look at my answer for the second question on this slide. So my working out looks like this. So again, from the question, notice that the 1 is not recurring. It's the 4, the 5, and the 3 that are recurring in this question. So start thinking about x, 10x. You may have thought about 100x or 1000x, but what we actually need in this question is 10,000x, because then we will have the digits after the decimal for 10x and the digits after the decimal for 10,000x matching up. So we had to go a little bit further with this question, but the process is essentially the same. We're going to continue with a subtract, which will eliminate these tails of recurring digits, which will leave me with 1,452 over 9,990, which is this recurring decimal presented as a fraction. Then I could simplify as well. So even though this is a more complex question, causing us to deal with 10,000x, the method and the steps that you use are still the same. Okay, 4 more questions for you to have a go at. So this time I've selected 4 typical exam questions. And you can see exactly how each question is set up. The language it uses show that. So in each question, it already tells you the answer that you're going to end up with. It already tells you that 0.27 recurring is the same as, is equal to 3 over 11. But where you pick up your method marks is by showing your algebraic method. How do you prove and how do you get from 0.27 recurring to this fraction? So these are very typical exam questions. You pick up your marks for your method. So for each question, could you show me a full algebraic method? How do you get from the recurring decimal to the fraction? Could you pause the video at this point and have a go at all 4 questions, please? Okay, welcome back. I'll quickly show you the solutions to these 4 questions. Solutions should look something like that. So for each question, you're thinking about x, you're thinking about 10x, you may go on to think about 100x or 1000x. You're always aiming to ensure that the numbers after the decimal point are matching. So then you can do a subtract and remove them from the calculation. Have a little look at my working out. Mark up your answers, remembering to simplify your fractions if it is possible. And then hopefully you've shown a good understanding of converting recurring decimals into fractions. The last little point to note is just on question 4. We started with a value of 2.515151 and so on. So because this value was above 1, you would expect to end up with a top-heavy fraction and therefore a mixed number. So 2 and 17 over 33. Very well done if you were able to get that 4th question correct, and just very well done in general if you were able to have a good go at all 4 questions. That would show a good understanding of the topic of converting recurring decimals into fractions.